Setting up your DataRay profiler is really easy. Most of our products use a single USB cable for both power and data, so just plug the USB cable into your profiler and then into your computer. If your profiler has a screw-locking USB port, we do recommend using those screws on the cable to attach it to the profiler. This can prevent unnecessary wear and tear on the USB port. Some of our profilers use a Gigi Vision connection. In that case, connect the Ethernet cable to your profiler and to your network adapter. You'll also need to plug in a power supply in those cases. Today, I have one of our M2DU stages as well. If you also have one, make sure you attach the profiler with the included hardware and then attach the USB cable and the power supply. Once all the necessary cable connections are made, you can now go to the software and begin running the profiler either with the green Ready button, the green Go button, or pressing G on your keyboard. Now that the profiler is running, it's a great idea to set your capture block. The capture block is essentially your region of interest on the sensor that you'll actually use. You can do that by going to Setup, Capture Setup Dialog. You can also press Alt-S as a hotkey. In the new window that appears, you can see in the top left that there's an image from your camera profiler as well as some resolution options on the right side. If I select these different resolution options, you'll see the capture block size change. You can also drag and drop this capture block to different parts of the sensor. If you need to use a different part of the sensor, that's a great way to use either a corner or the center, wherever you want to use. Generally, when picking a capture block, you want to pick the smallest capture block that encloses the entire beam, but you also want to make sure that the corners of the capture block are entirely dark. The corners will be used as a baseline subtraction, so it's important that they're not illuminated. Once you're done, just press OK. After you set your capture block, you'll also have to start to rerun the profiler, so again, press the Ready button, the green Go button, or press G on your keyboard. Now that we have a proper capture block set, it's a great time to explore different software views. So by default, the software will use the both view. This means it's showing both one-dimensional profiles through the crosshairs that are shown in the 2D image. Along with that, you have a full 2D beam profile, as well as a 3D representation of that beam profile on the right. In the top of the screen, you'll see an X, Y, a B, and an L button. These are your different software views. If you click the X button, now you're seeing only one-dimensional profile through one of those crosshairs. If I press the Y button, now I'm seeing the other one-dimensional profile through the other crosshair. And finally, there's the large button, which eliminates the one-dimensional profiles altogether, as well as the 3D plot, and will only show you a large 2D representation of the beam. Anytime you're using the software, you can normalize or unnormalize the beam profiling results by clicking these buttons at the top. Keep in mind, these are only affecting the view of the profiler. It's not actually affecting any underlying calculations or algorithms. As your profiler runs, it will fill an image buffer from the front to back to save your images. This is a rolling buffer, so once it's full, it'll repeat back to the beginning of the buffer and overwrite old images. At any point, you can stop the profiler and view these individual frames as you see necessary. To stop the profiler, just click the green running button, the red stop button, or press S on your keyboard. Now, I can use these arrows to navigate through individual frames. I can also click this button to view all the frames and select which one I want to view. Another important feature to look into is HyperCal. HyperCal is a dynamic correction that eliminates noise and sensor non-uniformities. Essentially how this works is periodically the profiler will take a very low exposure time frame and subtract this data away from the profile. This is really useful again for reducing noise, reducing sensor non-uniformities, and it's enabled by default. You can disable it by clicking this button here and re-enable it by clicking it again. Keep in mind, if your profiler is using a low exposure time, HyperCal can actually remove some of the data from the actual beam profile. So it's only recommended for longer exposure times, but don't worry too much. The software will warn you if HyperCal should be turned off.